Hello, everyone, and welcome. Today, Amy and I are going to show you how to use Percore's Cloud Server Navigator.
That's right, Gergely. Finding the right server in the cloud isn't just about the specs. We are both data scientists, and we know at the end of the day, it's about getting the best value for your specific data science job or your specific workload. We are all responsible engineers, so we should know our cloud costs before deployment.
Absolutely. But usually, this is a lot of guesswork and sometimes even some muscle memory. So, probably picking some previous generation of machines. And that's exactly what we would like to change at Percore. We are closely tracking more than 2,000 server options in real time, and we are giving you the latest insights.
It's super cool. And today we want to focus on a task that's deeply related to everybody. Everybody is building AI application now. And we're going to show you how to find the optimal server for LLM inference.
Yeah, and finding the best server for a specific task like LLM inference is not trivial at all. Like you're looking at CPU architectures or actual CPU models or GPU options if you're doing some CUDA build, memory speed, and so on. This is a long list, but how do you really know how fast your actual application will be on a particular server?
Exactly. And we can do a lot of specs on paper and do a lot of estimation, but that usually don't translate directly to the actual performance when we deploy it. Tasks like loading a large language model into memory or achieving a target token per second rate. These are very hard to estimate tasks, and if you are a practitioner, you will know it's a lot of guesswork. This could be a time-consuming and expensive process to trial and error. We're going to show you how to do all of this estimation before even deployment, and you can benchmark it and know how much you're going to spend.
Indeed. Thank you, Amy. So this is where our server navigator comes in. Instead of guessing, we provide specific benchmark scores for different tasks, for example, LLM inference. So you can see the list of more than 2,300 servers here, by default ordered by the best price, and some benchmark related to multi-core performance. But we have dedicated options for LLM inference speed, like I'm selecting a super small model for prompt processing with shorter tokens.
Yeah. So let me ask you some question here. So this is the Cloud Server Navigator. So with LLM inference task, we should probably choose a model first. And then this navigator will help me choose the best server, the cheapest server.
That's right. It really depends on your goal. For now, I selected a small model, and you can see that it's already incompatible with some machines. These ones cannot load even the small LLM into memory. But to go with a more realistic use case, let me select Gemma here, which comes from Google, and let's go for prompt processing with 1024 token lengths. And you can see that all the cheap machines are now out of question because those just cannot load that model into memory. So let me filter for servers which can provide at least 500 tokens per second. And you can see that we still have quite a few options here.
So if I rank by price, that means if I choose G2 standard, that will be my best option for Gamma.
I would say that's the cheapest option to achieve the 500 tokens per second target. If you're looking for the fastest one, we might sort by the actual benchmark score, and you can see that you can get a server which can deliver almost 27,000 tokens per second for a given price.
Oh, that's pretty valuable insight. So I would think as an AI engineer, you will either go for speed or cost, and sometimes you don't need both at the same time. So knowing that a server is unsuitable before you even try it is the best thing. So these servers are coming from cloud data from AWS, Azure, and GCP. How do I pick a server that's available in my cloud?
Yeah, that's a great question, Amy. So in the sidebar, we have a bunch of different filters for technical specs like CPU architecture and so on, GPU models, etc. But we also have filters for the actual vendor or for your required compliance framework, and you can select whichever you need. And some other views, you can even filter for a given region and so on.
It's
But
great.
let me get back to this table first, because we can see that there are some super performant servers for this task, but you might not want to go with the fastest option, right? Usually you want a cost efficient one. So let me also show how you can sort all these machines by the cost efficiency so that you can see the performance you get for $1 per hour. Or in other terms, you can see that this machine is super cheap, costs like 3.5 US cents per hour. So for $1, you can get like 30 of these, which provides an aggregated performance of more than 200,000 tokens per second. So around 200,000 tokens per second for prompt processing, which is like 8 million tokens in an hour for a single dollar. So that's 0.13 US cents for 1 million token. If you compare that to the SaaS pricing of AI model, that's like super cheap, right?
Yeah. And I would say my manager will be very happy I'm saving all this money for maybe a LLM labeling task where the cost efficiency is everything. If you can go through all the tasks at a cheaper price, everybody will love it. While we're focused on LLM inference today, this navigator actually can be used to benchmark other tasks as well. Some common use cases for finding optimal server for databases, web serving, general computing tasks. I think this is a super nice tool for everybody who does anything AI ops or DevOps related. I've seen a growing trend that everybody has become more and more full stack nowadays. So estimating server costs is a must do for every engineer now. Gergely decided to develop this open source. How come? What is your motivation behind this spare course project?
Yeah, that's a great question, Amy. SpellCore started 1.5 years ago, thanks to a boost from an EU grant. So we decided to keep all our data with public license and even the related tooling, open source licenses. And we want to keep that for the future. Although we do have plans to provide some add-on services to keep this project the momentum.
How do people use it? Except the Navigator, I believe there are more programmatic way to access spare course tools, right?
Yes, absolutely. Even this Navigator is an open source Angular application, but we are using our own API in the backend, which is publicly available, so anyone can use that. We also have SDKs for Python and the R language so that you can get all this data in a programmatic way. And we also provide database dumps, like a SQL file that you can download, a single file, and it includes all the data we collect from spot real-time pricing to all the 500 plus benchmark scores for all these servers. So that's like a sizable SQLite file at the moment.
What can I say? Gergely has always been a giver in open source community. I really enjoy working on spare course with him and hope you can leverage this awesome tool and save some money on the cloud. We will be making more videos on how to use spare course and how to save money in cloud and how to run more efficient AI apps. Thank you for watching today.
Thank you very much.